In this video, we're going to go over just a quick introduction to the spinal cord and spinal plexus by going over some terminology and labeling the spinal cord. First, I want to go over the importance of the spinal cord and where it actually plays into this whole process that we learned previously. So we know that we have, sensory signals getting picked up from the nerves, and then they get processed in the CNS. Well, it's not just the brain that's processing them. They do have to go through the spinal cord as well, and then actually back down the spinal cord so that they can be acted on properly. So here we have it again, PNS. We have sensory information going in. Unless this sensory signal that's being received by dendrites are being received by cranial nerves, one of those 12 cranial nerves, then it will pass through the spinal cord. If it's dealing with just cranial nerves, then we bypass the spinal cord because we are already in the brain. Okay, so in all other circumstances, we have sensory signals and it gets passed from those spinal plexus to the spinal nerves to the spinal cord, okay? And then it goes up into the brain where we have those integrative functions, those interneurons processing all the information. Now, the spinal cord can sometimes actually process the information without the brain. When you're dealing with reflexes, the spinal cord is able to process that and react without having to send the signal up to the brain. So other than that, though, it goes to the brain. And then when it's time to act on it, comes back down to the spinal cord and goes to the correct plexus where we can then act on it properly. Okay? So also, let's remember that gray matter made of cell bodies and dendrites and unmyelinated axons. White matter is made of myelinated axons. The brain has the gray matter on the outside and white on the inside, and the spinal cord is the opposite. Spinal cord has gray matter on the inside and white matter on the outside, okay? All right, so this is the spinal cord. And we're basically just going to go through and label these parts, okay? But the first thing that we want to do anytime that you look at a spinal cord, whether it's a funny drawing like this, a model, a nice actual 2D image, a real spinal cord, you always want to first identify anterior or posterior, okay? So there's two different ways that you can do this. First, you can look at these little divots here, okay, right here and right here. So this guy, he's kind of shallow, he's not very deep, just a little shallow dip. But this guy, he's plunging, okay? So we know this. These shallow little grooves, those are sulci, and the deeper ones are fissures, okay? So according to our terminology, this would be your posterior median sulcus, and this would be your anterior median fissure. Okay, so that would make this the anterior side and this the posterior side. All right, this would be lateral. Cool. Another way that you can tell is by looking at this really big bulge over here. Okay, so this is called the posterior root ganglion, okay? Posterior root ganglion, it's right in the name. So if you see that big bulge compared to over here where there's not a big bulge, then you would be able to say, okay, yeah, that's posterior over on that side. So everything over here is posterior and everything over here is anterior, okay? All right, so we've got the posterior root ganglion labeled. Now, what is on the sides of it? There's space here and there's space here. That is actually the same marking. The posterior root ganglion is just kind of in the middle of it, all right? So this is called just the posterior root, all right? Very simple. All right. So if we have a posterior root, then we probably have an anterior root, all right? So the lateral extensions coming off of the body of the spinal cord, we could call it, those are your roots. All right. Now let's actually deal with what's going on in the spinal cord. Now remember, we said that white matter was on the outside and gray matter was on the inside. With the spinal cord, we actually classify the white matter by calling them columns, okay? So this is the posterior white column. This is the lateral white column. And because this is anterior, this is the anterior white column. Oops. All right, so we have white columns. For the gray matter, they are classified as horns, all right? So you have the posterior gray horn, you have a lateral gray horn, and an anterior gray horn. All right? Okay. So we can all tell that this is definitely on the posterior side. The lateral is kind of facing anterior, but it's still a lateral extension. And remember, everything is symmetrical. So all of these extensions, they would be over on this side too, okay? So just for the purpose of the drawing, I drew it over here. All right. Next, we have to draw or label the structure in the middle here, okay? So this guy, this little hole, all right, it's actually hollow. And we call it the central canal. Right? So the central canal is actually hollow, right? And it has a very big purpose. This is where cerebral spinal fluid is created, all right? We know that cerebral spinal fluid in the brain was created in the ventricles. Well, the central canal is where it's created for the spinal cord, all right? All right, now, because we can't have any portion of, gray matter unlabeled, we have this structure surrounding the central canal, okay? Just gonna make it a square. All right, so this is called the gray commissure, okay? Gray commissure. So that is the gray matter surrounding the central canal. All right, can't leave anything unlabeled. Great. Now let's go back out over here to these lateral extensions. We have a posterior root and an anterior root, and here they meet, right? Right here, just right here is where they meet. That portion, just that portion, is what we call the spinal nerve. All right. Spinal nerve, where the anterior and the posterior root meet. And then it divides even further into another few extensions, okay? So this one extending directly off of the spinal nerve, extending directly off of where the posterior root and the anterior root meet, we have the anterior ramus, okay? Ramus means extension. We know that. All right. So we have an anterior ramus, and although it's kind of facing laterally, we still call it the anterior. Now, this extension over here is 100% on the posterior side. So that makes sense when we call it the posterior ramus, okay? And these two extensions here I kind of refer to them as on and off ramps, okay? So we have, let's say, one kind of goes down like this, and then one kind of comes up like this, okay? And we're talking about the information that travels down them, and we'll go over that later. But these guys are called the rami communicantes. Okay? Communicantes. Yep, that's right. So they are extensions, right? Rami is a plural because there's two of them. Communicantes, they are very, very important for communication. All right. Okay. So this is a normal drawing of a spinal cord, or image of a spinal cord, right? And we have all of the same markings, right? We still have, here's that central canal in the middle. We have that gray commissure around it. A is pointing to all of those white columns. F is pointing to all of those gray horns. We've got the posterior median sulcus and the anterior median fissures, so that gets us geared up for anterior versus posterior. We have roots. We've got a ganglion. We can see the anterior ramus extension, okay? We know that since this E is the anterior root and D over here, the posterior root, are meeting right here. It's not actually labeled, okay? That everything after that mark where the two roots meet would be the rami, okay? So only right here is it the spinal nerve. And then over here we have the anterior ramus, and this would be the posterior ramus, and these are your rami communicants, right? But what we didn't have on the other diagram that I wanted to go over was H, I, and J, okay? So we have meninges. These are your protection layers, all right? First, H, we have, this is your pia mater, okay? Pia mater. We know this from the brain. I is your arachnoid. I'm not going to spell that. Arachnoid matter. And then J is your dura mater, all right? So you can see those layers there on this model, all right? And then this is another image that we use, a model from class. This is good for practicing because everything is numbered, okay? So you could write 1 through, 30 on your loose leaf paper and then practice quizzing yourself, making sure that you can name, 8, okay, that's the central canal, 6, that's the lateral gray horn, 26, that's the spinal nerve where the two roots, 25 and 23, meet. 27, obviously the posterior ramus, because 29 and 30 are the rami communicants, right? All right.